Hello interwebs, welcome to Let's Fix Computers. Today I'm doing a bit of a walk around on this ELO ePOS system, that's electronic point of sale. This is basically a till, and I'm replacing the power supply on this thing. I took it apart last week and I've just received in the new power supply for it, and I'm going to fit that now. And I thought while I'm doing it, I'd just give you guys a walk around just to show you what the kind of way that these things are built, just as a bit of insight. This isn't really a walkthrough of sorts. I just thought, well, I've got it in pieces, I'd give you guys a bit of a look inside, because they're quite interesting, in my opinion. It's quite interesting to see how they're very similar to normal computers, but they've got a couple of subtle differences that makes them very strange to work with. The main one on this that caught me out was the power supply itself, but I'll get to that in just a moment. We'll just take some of the covers off of this, so I can get down to the access that I need again, and I'll just show you what's inside. Okay, so first of all, to remove the back cover here, we've got the main computer parts of it. Let's just find a way to balance this because it's a little unbalanced with that big metal plate removed from the bottom. There we go. Right, let's just have a closer look at that. Okay, so what we're looking at here is basically a micro ATX computer. As you can see, we've got a micro ATX motherboard here that it looks small, but it's just because it's in a small case. It's actually a full-size micro ATX board. It's quite an old one. We've got a normal CPU and fan here. I don't know what we've got actually sitting under here. It's an Intel LGA based CPU, so it's probably a late Pentium 4, maybe early 775 system. It'll probably be a Celeron or something like that. These things are notoriously slow. They put the cheapest CPUs money can buy in them. I mean, this thing's got 512 megs of RAM in it. It's only running Windows XP, so it doesn't need a huge amount, but again, it's sort of the bare minimum you can get away with to run these things. And then we've got a couple of fans going to a extractor fan system that's got a pair of 40mm fans? Yeah, 40mm fans there, which will be horridly loud and whiny. Even still, this thing's chock full of dust and it'll need a good clean out before it goes back to the client. But so that's the normal side of it. But that's more or less where the normal bits stop. But if you are working on one of these, as you can see, because this is all familiar, it is actually fixable. You could plausibly replace the RAM, you could replace the motherboard, you could replace the CPU. It's all standard stuff. Now these things, these till systems, a modern one will cost you about £1,000. They're bloody expensive. So if you're trying to fix one of these on the cheap, it's worth trying to do some DIY repairs. So let's turn it around to the other side. Whoop, the bit's falling off. And have a look at the place where I'm interested, which is the power system. Right, before I go any further, yes I am. I'm gonna take the screen off. I've taken most of the screws out of this already when I was disassembling it. So there's only one screw holding the screen on at the moment. I didn't bother filming the disassembly because due to my unfamiliarity with these things, it was a bit of a long and arduous process that doesn't make for an interesting video. I'll lay that down and just balance that backwards like that to give me a bit more working space. Right, now I've removed all of the screws bar a couple here, so we'll just take these retaining screws back out so I can remove this panel. Under here, I'm going to remove this one separately because this bit comes off as well. Right, so first of all, behind this plate we'll find an ordinary laptop hard drive. Obviously the wires have already been disconnected. Bog standard SATA interface, 80 gigabytes, cheapest hard drive they could find at the time. Then on this one we've got a couple of speakers and a power button and so on and so forth. Let's just unhook these to give myself a bit more access. You can just bend that backwards. And now if we take a closer look in here, in this point, again, I've disconnected these wires, but this is where the proprietary system comes in. This board here, I don't know the names of any of this, but it's got an IDE connection going to it. And from that IDE data connection, it's got all of these extra bits. Let me turn this around. It's got all of these extra ports on the other side here. We've got a ton of extra USB ports. We've got another 4 COM ports, and we've also got some proprietary power outlets. Now this is where it starts getting exotic. These are 12 and 24 volt outputs here, and these are designed for connecting up additional till peripherals such as receipt printers, card readers, that kind of thing. Now because it's got a 24 volt outlet on it, this thing has an exotic power supply. So from this main power board here, we've got some of the extra cables. We've got the SATA power cable here, we've got the auxiliary power cable that goes to the CPU on the other side here, and a few other extra bits and pieces that go to various power points. One of them will go up to the screen to power that. However, because these systems are running on 24 volts, you can't use a standard power supply. Now this thing, initially when I took it out, it looks like a bog standard Flex ATX power supply. This is the kind of thing that you see in low profile servers, in shuttle PCs, that kind of thing. However, it's got 24 pin ATX, but you can see a completely different connector for everything else. This thing looks like an 8-pin auxiliary CPU connector. However, it doesn't carry just 12 and 0 like a normal one would. It's got 24 volt lines on it. And that's why this power supply was a pain in the backside to find. I couldn't actually find a replacement for one of these on eBay or anything. What we did in the end was I spoke to the company that originally supplied this, God knows how many years ago, to the client, and they just happened to have a couple of them sitting in their breaker pile out the back with some working power supplies in them. The ones they had got broken touchscreens on them and that kind of thing. So they very generously offered to pull one of these out of their breakers and send it over to me so I could fix this unit for them. So what I'm going to do now, I'm going to put these covers back on and fit this power supply. Now, I think I can probably just drop that straight in, but before I do that, I'm just going to give this thing a bit of a dust down. Just get the worst bit out of this side. The other side where those fans are, we'll take an air compressor to that when I've finished fitting the power supply. I wonder if they were generous enough to dust this thing properly. I'm going to give this a compressor shot just in case. Just in case you are trying to fix one of these yourself, the giveaway that let me know that it was a failed power supply from the get-go was that we had standby voltage but no initial power. So in other words, when you plugged it in, we had a red light indicating standby, but when you push the main power button, nothing happens. That is a classic sign of failure from a Flex ATX power supply. Your standby voltage works, but there's no main ignition, if you see what I mean. So now how the hell does this work? I have to feed this right down to the other side of the computer. So let's just push that through the gap that's down the side here. I'll pull that out the other side in just a moment. Just fold that back and we'll just plug all of this stuff back in. We've got an extra SATA lead here. It can take 2 hard drives, so that's what the spare one will be for. And then to follow that up, this bit slots down there. I think this is supposed to be like a mounting bracket for the power supply, so you can just pull the power supply out. However, it's somewhat redundant because you can't pull the cables out with it anyway, so it was entirely useless and just got in the way. Now we'll reconnect this hard drive back up. This is a tight fit, the cables are not very long. 1, 2. And now we've just got to guide all this back down. Just make sure those wires lay flat. We don't want any pressure on the underside of the drive. There we go, that's nice and happy. Good. Now we've got that nice big metal plate on the bottom, it should balance a lot better. Right, okay, I'm going to go and air blast all of this now, so I'll be back in just a moment. Oh. Unbelievable. I am actually going to have no screws left over. I was almost certain that I was going to have at least a couple of screws lying around after I finish this one. Bang! Okay, that's it. This side panel was missing. The client probably has that, and that will basically be a cover panel. So you plug all your bits and bobs into the side, put the cover back on and have your wires coming out the bottom, and you get a really nice flush setup so no one can see all the wires trailing around. And that's it. That was an ELO touchscreen ePOS system. Thank you very much for watching. I'll see you all next time. Goodbye for now.